All right, hey, here's what I'd like you to do. Take your piece of paper. I'd like you to fold it like a hot dog, longwise. Hot dog. So it's like that. Fold it longwise. Fold it in half. All right. Once you have it folded in half, what we're going to do is you're going to, I'm going to have each group in here a scissor. You're going to cut up to the point where you fold it. So you're going to only cut half the paper. You're going to make this cut first. Okay, that's going up to the top of the middle. Okay, you're going right in the middle of the paper for that first cut. Okay, so it's going to look like this. This is your first cut. Right here. So it's going from the bottom up to the middle line. Okay? Then, yeah, we're going to actually cut. I'll hand out scissors here in a minute. So that's your first cut. You're not cutting the one side, just the other. So it's going to look like a broom. Okay? Question.
Do you know when the last day of school is?
23rd, I think.
23rd? Hey, is that cute?
Okay. Alright.
What?
Hey. So, you're going to make this cut. After you're done with that cut right down the middle, up to the top of it where they meet at the middle, then you're going to make 2 more cuts on the top and bottom of it. That way you have a total of 6 strips on the one side. You can keep them equally balanced. The reason why I have you cut the middle first, that way you can kind of guess where the 2 cuts need to be on either side of it to make a total of 3 strips so they're about the same size. Remember, you're only cutting the one side.
Hey, Jamie.
Okay? So, take a piece of paper.
She went to
Sorry, just grab one right here. Okay, or not.
I'm down and go to Harvey.
Alright, I'm going to hand out the scissors. Each group only gets 1, so just be careful with them. Make sure you're making your cuts.
Actually, no, I do.
I would definitely not trust bro. Yeah, I can't bro these things.
Oh, that's good.
Cut paper.
You messed up.
Hot dog style.
I know. Is that the middle?
I have to see this already.
You could definitely hurt someone.
That's what I was just saying. Like, put it in your.
Hey, make sure we make our cuts. This is what I want to do. So Jamie, if you're just walking in, fold it like a hot dog. Okay, long way. You're going to make your cut down the middle up to the ridge line. And then you're going to make 2 cuts on either side of it, so there's 6 strips of paper total. Cut the middle one first, that way you can kind of guesstimate roughly. Make sure you get your phone and catch. Hey, Jamie, it should look like that. Okay, alright.
Look like mine. Mine's gonna be freaking amazing.
Okay, watch line.
Watch the rain with that.
Grade A. I'm gonna become a sculptor.
Does this have to be very exact?
No, it just has to
Oh, it's
mimic
got
mine.
perfect straight lines and everything.
Yeah, just like
Yeah,
this.
Mr. Dagger, can we put that desk down?
I can't really unwrap it lower. Nick. She won't for me.
If I come, yes.
Okay.
That's more than she is.
Okay, make sure we have our cuts. Once we have our 6 strips of paper, remember you're only cutting the one half of it, not the other half.
Do you guys have your cuts
Better
yet?
handle it the right way.
Really?
Yeah.
You guys know what your scissors now. Hey,
I'll take those after you.
Oh my god. Wait.
Ow!
I did it.
Oh my god.
What are you doing?
It's just a. I can't see the wrap.
You only cut one side.
Yeah.
Rip around.
It's a natural.
Rip around.
You're giving scissors.
I didn't cut it in half.
Yeah.
It's still weird.
Alright, so keep going. Hey,
Nathan. It doesn't matter.
Alright.
Nathan, what'd you
Hey,
do?
at least it's not broken all the way.
1, 2, 3, 4, 5. I had 7.
Everyone else
How
good?
do you mess up?
Actually,
Did you get
How do you mess up that piece of paper? That's what I was.
it takes 3 years.
Yeah, it's fine. It's not
You
bad.
scissors.
You guys did your cut.
I'm just really good.
Yeah, slowpoke.
Well, they measure them.
That's your fault.
Good.
Actually, no, it's not. I made sure it's not contrast.
I've done it the wrong way before. I've done it this way.
Okay.
Perfectly symmetric. Zach, you got the
I'll place mine.
You got the candy. You sound awful.
Actually, your parents want you.
No. Someone's a guy.
But they're still together at the same time.
Yeah.
Really?
Is actually an FFA? Yep.
No.
Yeah, you're not.
Are you good?
Yeah.
Oh, you're going.
That sounds like
These are hot pieces.
That's how not to do it.
Why didn't you?
That's how to do it nicely.
And
Jimmy on the left, you knew.
Okay,
Have all that stuff
we
done.
good? Okay.
On the last page, you
All right. Hey, here's the thing I want to do now. All right. Here's what I'd like to do. I would like you to hold your piece of paper that you have now. I'm borrowing yours for right now. All right. Okay. I want you to hold it so it's kind of like a book in front of you, like this, where the piece of papers can fold out in front of you. Now, if you're left, you can turn around. It's totally fine. But you need to have the actual tabs facing up. So the tabs face up in front of you. Okay. Here's what I'd like you to do.
alright, I'm confused.
Okay. You have to be worried there. All right. So.
So your parents also do that.
Whoa. I wish I was that artist.
Okay, so this is my little book, and you've now made cuts.
Ward, you should be an art. You should be an artist.
So,
5 lines.
okay, so let's say you made your cuts. Now, here's what I want you to do. On the first tab, right here at the top, up in the corner, kind of right near the ridge, I'd like you to write 6.3. It can be in kind of bigger numbers, but again, it's just in the corner. It doesn't have to be super, super big. We are going to write on this actual tab here in a minute, but you need to put 6.3. Then going down, put 6.4, 6.5, 6.6, 7, and 8. Okay, so you should have 6 tabs total. Okay, these are the theorems. Okay, now you should have nothing else in front of you, just this little like booklet thing with your little tabs. So again, this is basically what it should look like if you're looking at mine. The numbers should be in the corner somewhere. They can be kind of big so you can read them. That's what it should look like. Okay, numbers down the ridge.
Oh, I'm such a loser.
We're getting artsy today.
Numbers should be down the ridge. Okay.
Bro, you stupid.
All right, good. All right, perfect. Now, here's kind of the interesting part. Okay, here's what I'd like you to do. I'm going to give you about 5-6 minutes here. I would like you to be in your little group. So, Brock, I'll have you commit to this group, and then I just will have you commit to that one.
We're already committed.
What I'd like you to do is I would like you to talk amongst your group and try to see, can you, to the best of your ability, write down what those theorems were. Okay, these are the 2 theorems, or these are the 2 sets of theorems we've done the last 2 days in here. Okay, we've done 6.3, 6.4, 6.5.
I know what 6.3 is.
Okay, hey, shh. So, talk amongst your group, write it down to the best of your ability on that face where it sits right now. Okay? I'm going to give you 5 minutes, talk amongst your group, go. Okay?
You don't know anything.
No, you're not allowed to use notes.
Alright,
Okay, so again, you're writing down your attempt
That's my sector.
at what these theorems are right here.
number
So-
3,
I had to refer to my notes that I
Yeah.
took about Dennis's.
Okay, so try your best to try to write it down.
I know it's something, I think the last 2 are dying.
No. Is that what I was
Whoa, we got
Okay,
one other.
try your best to try to write it down. Okay, talk amongst your group, try to see if you can figure it out.
Don't understand.
Do you know what's going on?
Hey, in 2 minutes, I'll give you, hey, in 2 minutes, I'll give you some more clues. I'll give you some more clues.
Why is it?
This is
opposite
not
side.
Why?
Opposite side. That's all we need.
It freezes, it's not a freezer, it's a fridge. So why don't you put it right back?
Which had more table partners?
I could
I'm
probably
worthless.
The next one was
buy it from the vending machine. Oh wait.
Yeah. Hey, can we work with these guys? She wasn't here. It's just me.
That's not,
Work, fine.
No.
fine.
What's 7?
Hey, that doesn't
No,
count.
they had 7 already.
You have multiple.
We're not gonna tell. Don't tell.
Nay.
You want to see it? No, I don't.
Which one? That is what you're at.
Opposite side.
I can't read your handwriting. You don't have anything.
I was right.
Ha.
I thought you were bad.
I wouldn't put it on.
Well, you could be nice.
No, don't get that.
One of these is opposite.
One of them is
Hey,
That's savage.
What's it say?
But you just learned too.
Dive for work. I still
I won't
can't.
learn anything else.
Howdy, Pig.
Just one.
I think 3 deals with
Alright. Hey, okay. Who needs a clue here? Okay, here we go. Okay, probably a lot. Alright, if you're paying attention, here we go. Here's the clues that could potentially help you out. And again, you just have to paraphrase, you don't have to be perfect. Okay? The top two, when you're at the top two, they deal with opposites.
opposite.
So that's a key word that you need to know.
Okay, so we're.
Okay? The last two deal with diagonals.
I knew that.
Okay? Now, the middle three. The middle three, so it's an overlap. These are the middle three, 6, 4 to 6, 6. Those three deal with angles. Okay, those three that are highlighted in green. Alright, that's the only clue I'm going to give you. I'm going to give you another 2 or 3 minutes here. Let's see if you can somewhat piece these together. And then I'll explain why I'm having you do this.
I don't know.
And that's all I know.
I don't want to erase all of
I
it.
got the first two right.
Opposite.
Oh, you're painting your tractor red.
Oh,
No, I got no.
3 is opposite walls.
Really?
Thanks, Brody.
Did you watch the game last night? No?
I
It was 68 to 64.
Hey, you should see the other guys. Oh, we're out of the tournament, but.
Wait, don't hold on.
Opposite
It's
angles.
tough for the rest of the season.
Walls.
Hey, Ward, did Iowa win last night?
No, we lost by 4.
No, I think they're completely done.
It was close.
Lost by
I'm
4.
honestly surprised they were that close to Texas. When I saw it. I saw it on Instagram.
Didn't have Obama play though.
They kind of
Because
figured.
he's injured. That's why.
You said they didn't have
He's
Obama
recording
play
our
though?
class.
Obama.
Style on
He's
that.
their star.
Oh, wait, do
No,
that.
he's going to the NBA this year.
One second.
Iowa. What more football, so.
Honestly, that's what I got.
Wait, what?
The other one?
If I don't go play football at college, what?
What?
Is there number 4 opposite?
Maybe there is. Then I'm driving truck for the rest of my life, so it's okay. It's just,
Okay.
Oh, yeah.
It's kind of simple.
Okay, one more minute. One more minute.
Does anyone actually know it?
Yeah, there's a couple that
Dude, I know
almost all.
the first
Yeah.
Couple. That's good.
Yeah, we all.
No, I know. She's off mine.
Oh, hey,
Last one is diagonal bisector. Like, I don't know actually exactly.
Exactly how it's
That
was a Fortnite
Okay, here's what I can do. Hey,
triangles.
hey, put your pencils down. If some of you are sharing those, take those away. All right. Okay, here's what I'd like you to do. Okay, now, think back to that first time before I gave you the clue. A lot of you were sitting there kind of spinning wheels. There's a couple people in here that, kind of filling in a few. Okay, before I give you my little clues. Here's why I did this. Number one, I was going to do a pop quiz today. Because I noticed a lot of people weren't paying attention yesterday.
I would've got 2 right.
So,
I even wrote in my
I
notes.
was going to do a pop quiz and quiz you on which theorem was which. Because that's what we've been talking about the last 2 days. But I decided not to today, and decided that maybe we should review them one more time. This number one, I know there's some people gone, so they've been excluded. But some people wouldn't have been, and you've been here for the past 2 days. So I want you to just think back to that first initial 5-minute period when you sat there and you spun your wheels a little bit, and you maybe didn't have any, maybe you had 1, maybe you had 2. So there's some people that did have quite a few of them there. But that's something that easily could have been quizzed today, because we covered it in class. Keep that in mind, okay? Now, this is hopefully kind of a wake-up, kind of a call for some people that I should pay attention a little bit more on these theorems, especially when we're going through them in class. Or I should wrote down better things in my notes instead of, just kind of watching what I was doing. Those are little things that I wanted to keep you kind of well aware of. Because this chapter, we're only in the second section. What's that second out of like 6? We already have 8 theorems. 8.
Jesus.
Okay, think of it. We're up to 8. We're up to 8. We have the next 2 sections we're doing have another 8 more. So we're gonna try to do this. We're gonna try to do this the next couple days in here, where when we get new theorems, we're gonna try to do different graphical organizers to help us out. Now, here's what I like. Okay, I would like somebody in here.
I got it.
If you have it, just
I got
state.
it. I guarantee I do.
Okay, so diagram the first one then.
Opposite sides are the same.
Okay, sorry. Alright, opposite sides are equal.
I got the second one.
Okay, hold on.
I have a second.
Okay, hold on. Where's my photograph? Oh, I know where it's at. Okay,
I'm 6'5".
What's that writing?
okay, alright, here we go. So, okay, stop. Alright,
The entire
hey,
time.
6'3". Dyer, say again for me one more time.
Opposite sides are same.
Boom, opposite sides are equal. So what I'd like you to do, open up the tab. Open it up on the inside. And on the inside of your tab, that's where you're gonna write your theorem down. So on 6.3, you're opening up the first tab, you should write down a parallelogram has opposite sides congruent. That's your right on the inside. Now on the front of the tab where you guys attempted, or at least some of you did, actually write down the theorems, on the front, what I'd like you to actually put on the front is just write opposite sides theorem. So put that somewhere next to the theorem 6.3. Put opposite sides theorem, because that's the name of the theorem that we're going to call it. Okay, that way, this is to help you out like visually that you know what the name is called, and when you open it up, now you know what the theorem is. So it's kind of like a flashcard. So you can kind of like, you can test yourself, so you can read the name and then open it up and see what the actual theorem was. Now, on the inside, the booklet, this part, the flat piece of paper that we didn't cut, today, as we go through examples, because we're going to have little pods today where we try out problems, each example we're going to do, we're going to put those as pictures off to the side. So when you open it up, you see the definition and you see an example right next to it. That's what we're doing today. What?
What do we call it?
Just put the name, opposite sides theorem. That's what I would call it. That's what we call it. Opposite sides theorem, that's 6.3. And then these are the names you should put on the inside of the tab. So parallelogram has opposite sides congruent. Opposite sides are equal. We'll go through an example here in a minute because we're going to do a bunch of pod work today where we try out problems. And I want to see how well we can do here.
We gotta do like a picture here. Yeah, I started with that.
Okay, we're good?
Golden.
No.
Okay, who has the fourth one? Thank you, Dyer.
Me.
Okay, fourth one, please.
The plot is a parallelogram, the opposite angles are equal.
Opposite angles are equal. So the second tab you should open. On the front of the tab, so now we're on the second tab here, you should have 6.4. You should write opposite angles theorem. So put that on the front, opposite angles theorem. On the inside of it, when you open up the tab, you're absolutely right, Isaac said it, opposite angles are equal if it's a parallelogram.
Do the opposite, so I already wrote the definition here.
That's fine, do the opposite then. That's fine.
Angles here?
Opposite
Yeah,
angles
this is
theorem.
the theorem, bro.
Yep, opposite angle theorem. Opposite angles are congruent. And again, all 6 of these, why we're making this little handout, this will help us for all the properties of parallelograms.
Can I use this on my test?
No. Nice try. but no.
Worth a shot.
This will help us in the homework so you don't have to flip back and forth.
Actually,
isn't it? So,
I'll get it.
Nice job, actually.
You see, if I had my notes on this, I would have aced.
Ah.
Give it a try.
opposite angles are equal. All right, so thank you, Isaac. So somebody else now, do we have 6.5? Okay,
I got it.
Bo, what do you got?
Angles on one side, add the angles on the other.
You're absolutely right. Now, does anyone happen to know what the word is? I agree, certainly.
Supplementary.
No? Oh, supplementary. That's one of the key words. And what was the other word? Start with the letter C.
Consecutive.
Consecutive. So, if we're going to the third tab, I know some of you are still writing. The third tab, I'd like you to put consecutive angle theorem on the tab. I don't care if it's on the inside or the outside where you have it. Consecutive angle theorem. On the inside of the tab for 6.5, this is what I'd like you to put. Quad is a parallelogram. The consecutive angles are supplementary, which is one of the keywords you guys said. Again, that should be on your third tab. Consecutive angles theorem. This is 6.5. Again, we had these names as we went through them the last couple days, but I'd like you to put the theorem somewhere on the tab so it's on the inside or the outside. I don't really care. I don't know how you're doing it personally so you remember it, but then you need to have the name. Now again, those 3 we had names. The rest of them we don't, but we'll just make up a name to help us remember it today.
Purple.
Okay, so that was your top 3.
Right.
All right, next one. Brody, what do you got?
It's with 90 degrees,
Okay, I agree.
and if 1 equals 90 degrees, they all equal that.
Boom. So, your next theorem. So we're on the 4th tab. I'd like you to write the right angle theorem. Right angle theorem. Now,
Is that like the official name?
no, we're just making that up.
So it could be like, but like, you write, so then we remember it.
Sure. Okay.
You're an idiot.
Okay.
You're
Now, now, hey, now, on this actual tab, somewhere on the tab, I'd like you to write the word rectangle on this fourth tab. So you're writing the right angle theorem, but I would like you to also put somewhere on it, put rectangle. Okay? The reason why is when we get to that, the 6, 6, which, bro, you're absolutely right. If one of the angles is a right angle, then they're all right angles. That makes it a rectangle. So that's what you should be putting on the inside of that 6, 6 tab. Again, we will be adding pictures to this. So when we flip open the little booklet, our little tabs, we will be putting pictures in here so you know an example of that theorem. So it's a more visual aid to help us out remember it. Again, 6, 6 is called the right angle theorem, or rectangle theorem if you want to call it that. But we're going to use 1 right angle leads to 4 right angles. Okay, and again, not an official name for it. We're just kind of making up the names to help us remember it for right now. Okay, 6, 7. So thank you for the volunteers. Mo, you already volunteered. Somebody else now. 6, 7.
Is this the one where the angles bisect, or is that the last one?
No, something bisects. Not
Well,
much.
diagonals bisect to make equal triangles.
You're kind of mixing two together.
The diagonals, no, the.
Something about
Diagonals
Equal
bisect
triangles.
each other.
Hey, say it.
Diagonals bisect.
Diagonals bisect each other. So what I'd like you to put on 6, 7 on that tab, I'd like you to put the diagonal bisector theorem. Diagonal bisector theorem. So that's 6.7. Diagonal bisector theorem. And again, if you didn't hear Caitlin here, she talked about that in a parallelogram, the diagonals will bisect each other. So I know, Isaac, you were kind of there, you're kind of mixing 6, 8 with it a little bit.
Yeah, a little bit.
So the diagonal bisector theorem. Now, what this one states is that when you have the diagonals in your quad, right, your parallelogram, they're going to cut each other in perfect halves. So we'll see an example of that today where we look at some numbers with that. My goal is after we're all done today is we'll have some pictures to go with these. So you'll see an actual example of the homework, and then you can put that as a picture right next to it. So you're like, oh, that's how I'm going to use it.
Oh, I like it.
Yeah. A little visual aid. Help us out. Okay, now the last one. 6, 8. I know a lot of you are still writing. It's fine. 6, 8 though. Okay, Mo, fire away.
The diagonals make equal triangles.
Diagonals make equal triangles. So what we're going to call this one, 6, 8, I'd like you to call it the diagonal theorem. Just diagonal theorem. That's all I want you to put. Now if you want to call it diagonal triangle theorem, fine. It's just however you want to remember it, that's what I want you to write down. So I just think it is the diagonal theorem. So what this one states, if you didn't hear Mo, when you draw a diagonal in a parallelogram, it separates the parallelogram into 2 equal triangles. And it's only one diagonal, not 2. Single diagonal. One diagonal separates the parallelogram into 2 equal triangles.
We put 2 congruent sides. Yeah.
So I would personally call this the diagonal theorem or diagonal triangle theorem. I don't really know how you want to name it. Because again, these don't have official names. I was just kind of making these up so it helps you remember them. But again, the goal is, once we get going through these examples in our little pods, is to take one of the pictures that you tried, and that's the one we're going to put in the little, on the sheet. And again, we'll go through the problems before we add them to the sheet. That way you know how to use it correctly, if you're not quite sure. Now, I will hand out problems here in a minute. Each group will get 3 pictures. You only have to pick one of them. Some of the problems are ridiculously easy, some are ridiculously hard. I want to see which problem you pick. Because some problems, I'm surprised by what some people have picked today to actually solve, and they actually did them right. So I'm actually really surprised. Some people are very comfortable with the style of math they have to do. But these properties are the properties we're using. That's what we're doing. Okay? All right. I'm going to walk around the room. I'm going to hand you a group of problems. Do not write on these. Right? So you'll need notebook paper. So pull out some notebook paper. You will not be turning these in or anything like that. But I will ask your group to go up to the marker board and actually display how to do it. So you will have to go up to the marker board at some point today. Okay, pick one out of the three. I'll explain here in a minute. Pick one out of the three, and I'll pick one out of the three. 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 All right, now, hey, let me explain. Okay, for those who are a little confused on what you're looking at a problem like this. Okay, hey, everyone should look at the board. If your problem has X, Y's, A's and B's, Z's, whatever the letters are, you have to find what the number is, if that's the problem you chose, because you're only picking one out of the three. Okay? If your problem just has numbers in it, like this one, you're trying to figure out, is it a parallelogram? It's a yes-no question, but then you're going to have to justify why, yes or no. Okay, I do not require that you know your theorem numbers, but what I do require is that you know how to show how it works, because you're going to be coming up to the marker board to show what your answers are. Okay, so if you pick this one, you have to say yes or no whether it's a parallelogram or not. If you're doing one of these, you have to find what the numbers are for X, Y, and Z. Does that make sense? Okay, I'm going to give you 6 minutes. Pick one, work together, see if you can figure it out. And trust me, work together. You only have to do one out of the three.
Okay guys, look at this. I'm gonna do...
And then I'll walk around the room and I'll pick one of those people's problems.
Ward, is this right?
I think that's about a picture too.
Oh, in there, but I put, yeah.
And one.
6.4 opposite angles or...
That's 6.3. What's 6.4?
Yeah, oh.
Oh, this one's probably easy.
Side.
Well, opposite angles are 6.4 is opposite angles, but how does that prove? I don't have opposite angles drawn.
We have to draw a picture and then do the marking. That's why you're talking.
You got a picture.
That equals 35, and then you take that away, so it's 1.0.
That's what we picked.
We can have a good weekend, Jack.
Alright, which one do you guys
You can have a good weekend.
Good. Pretty straightforward for me.
No, but are you gonna have a good weekend?
Okay, which one do you guys picking?
Yeah, what are you gonna do?
Oh, that was...
That's pretty good. Yeah, that's pretty good.
Sounds easy. I wanna see if I can do this.
Which one do you guys
You're gonna be dead. You just play Fortnite as it goes.
That angle would have to be related to the...
They really don't like playing with Kevin, so.
If he was
Bad handwriting.
okay.
Oh.
It's a shot pencil.
Because my other pencil's at my house.
Alright. Hey, when your group gets one done, let me know, and I wanna just double check your answers before I send you to the board here in a minute. Okay?
I'm gonna read you
We
this.
spent a lot of time on it.
This one had pads in that
So,
one. That one had.
I figured out
anything off. Ward.
What do you guys? You guys
Yeah, I
have
don't know.
Yeah, good. And the other one. Good. Okay. You guys are ready to go? Hopefully.
I'm done.
Thanks.
Ward, did I do this right? Is it 36?
What do you do?
We did the math. Well, I did this one, but they're doing that one. You want me to see if I can do this one? Because it's hard to me.
Downstairs.
It's not hard.
She said it was hard.
Boy.
Because I had to do 360 and
You started smoking real bad.
I did my head.
Hey.
Jack's
Doesn't want not doing the work over there.
Jack's insane.
Ward. I'm stumped.
You stump?
Well, this is 30. Right, so that's 66.
3.
No, I am.
My grandma that was it.
And this.
I might as well just say it to myself.
I
still think it's stupid why he's grilling us about it, to be honest. I'm not gonna be here for it. You might be here for it.
Yeah, you can do it that way. But that'll be really hard to find.
But the 70,
One Saturday, one week next year, but I won't have him here after
For
that.
140, I mean, it's 206, and then you take away the 100 from both sides, you got
306.
Yeah, what do you?
Then you got 76 more.
I know.
36 plus 36 is 72.
You're thinking way too hard.
Even if it's
That's
four,
right.
yeah, she could.
Hey, Dad. Hey,
Right
where's
here.
the
So, if you plug the 5 back in,
35.
yeah, that's 35.
Irish just doesn't do
That doesn't
that.
have to equal
No, but these two have to add with this one.
180.
180. So,
35.
Everyone who was just
Okay, so-
smiles and thumbs up.
Hey, word. I'm leaving. Maintenance here, actually. I 115 stuff. I was stuff.
I ever
Right. I know you ripped the 2 of them.
I didn't.
Yeah, you did.
No, I never.
I remember. He didn't rip it, he fixed it.
I watched you rip it up.
Okay.
23.
I watched you rip up Theorem.
Job, me too.
I literally
Wait, what's the one that has to equal, what term was it that has
Consecutive angles.
to have to equal
This one
100?
also, it's like missing a line.
He ripped it up in front of us. What am I missing?
It's the
2 days later, you know, when those bites it up.
So, the triangle there, right?
It's the one that has to equal.
You have to clear the shot.
Look at it's missing a line. You ever see that? 115.
Wait,
I'm pretty. I'm going to
Alright.
What?
I know.
We
But,
were trying to
alright.
fix it across.
Okay, hey, first group. I would like you to go up here. First group.
So all of us have to
Yep.
go?
Alright, here we go. Let me put up your problem. Alright, hey, all eyes up to the board, please.
That's cool.
Hey, you don't need to draw.
Why not?
I'm about to show you why. Aha. Okay, if you want to erase that little TV, just the one. Don't erase that. Alright, here we go.
I'm not black.
Yeah, you are.
Okay, hey, here we go. Pay attention.
Zach, can you please explain what you're doing, buddy?
No.
Let him write it out there and I can explain, or his group can explain.
He's just copying off the she did it.
Oh, thank you.
I'm right, ain't I?
No.
Yeah, I am.
I got blind.
Okay,
I got
hey, can somebody, it doesn't matter which one of your group, can explain why you chose that for why? I agree with the number, but why?
I vote Zach explains.
Hey, calm down. Let him explain.
I'm not.
Because these two are.
Okay. Caitlin's markers on the picture kind of explain why the certain walls are equal. Now, does anyone happen to know what theorem number that is?
The angle bisector.
Angle, or the diagonal
I
bisector.
said 7.
6, 7. Hey, in fact, this problem, I want you to put as the picture next to 6, 7. So in your little booklet, I would like you to open up that tab next to 6, 7, and this is the picture I'd like you to draw and put all the labels in it. Even the markers that Caitlin has put on the board, you need to have those on your picture.
I'm a little really short.
Yep. It could be on the inside of the actual booklet. It could be like if you open up the tab, it could be right here.
Oh, okay.
Or if you have a blank spot on the back of it, that's fine. You just have to put the picture next to 6,
I was
7.
putting anything else in there.
Yeah, because they're gonna find the other letter here in a minute. Or explain how they found their other variable.
No, I mean like besides this picture.
No, this would be the only one next to 6, 7.
Wait,
So
do we have to have the numbers too?
yeah, you have to have the variables and all that stuff written in there, and actually show the work off to the side that Zach very nicely put on the board. So he showed you how to find y. And then the group still has to finish. They still have to show you how to find x, which I think you get the idea of how to do it. But this is a perfect example of how to use 6, 7. The diagonals cut each other in halves so that certain pieces are equal, and they're showing you which parts are. Okay, does somebody want to, from the group, I know Zach already wrote, but does somebody want to come up here and show how to find x from that group? Okay, Caitlin's got it. Okay, just put it off to the side. Okay, hey, if you're still writing, Caitlin's going to put up how she found x off to the side as well. She's going to put it in a different color. And again, if you can't see, I think you get the idea of, I'll explain here.
You want a minute, but we will.
Boom. Okay. So Caitlin just put on the board, she figured out how to find x. X is 7. She set the 3x plus 4 equals 25 and actually solved. Questions, comments? That was very nicely done, group. Very nicely done. Okay, we good?
7. Oh, why equals
Yep. Okay, does everyone have their picture next to 6, 7? Okay. Gentlemen, I'm gonna have you guys go next.
We'll go next.
Why is 7? Oh, why is 18?
You got the Ryan Sanders. Ryan Sanders.
Okay.
Sanders.
So I got like 200.
Okay. All right. Here we go.
Like 85.
Next group. I think it's my gentleman right here in front of me.
Yeah, he's scared a little.
There you go. That's your problem, right?
There you go.
All right.
I can.
We'll go Markings.
Are you kidding me?
Okay. Okay. Hey. All right, gentlemen. Open up so everyone can see. All right. Their job on this problem was to figure out, is this picture a parallelogram or not? So they have to show enough information to justify that yes or no, that it is or is not a parallelogram. So,
Good job, Jack.
okay, so what they're putting in here is they're throwing in numbers. Now, here's the problem. Does that justify that it's a parallelogram with what they have written down so far?
No.
Yes.
No.
No.
Right now, they're writing 6.4. They're showing you how to use 6.4, but it isn't proving that this is a parallelogram yet. They're missing one theorem. Now, I think they're about to write it down here in a second. 6.5. Now, can you gentlemen explain 6.5? Good. Good. This part right now that they're writing down is the part that explains why it's a parallelogram. That doesn't matter the direction they go, clockwise or counter. The numbers actually do add up to be 180 on the two that they pick, side by side. Those are called consecutive angles. That actually explains why it's a parallelogram. So it is a yes. All right, here's what I'd like you to do. Okay. Thank you, gentlemen. All right. Here's what I'd like you to do.
Yeah, I just did that. I don't know. She said you said
We go.
Hold on. Okay. I'd like you to open up the tab next to 6.5. This is the picture I'd like you to put next to 6.5, and I want you to write down, like, draw the picture, put the numbers, and I want you to have written down somewhere this. This is what I want you to show. That actually explains why it's a parallelogram, because the consecutive angles actually add to make 180. Now, they did some other interesting things where they bounced numbers around, which was really clever, but it wasn't necessary to do that. They were just showing, without a doubt, that we have a parallelogram because the consecutive angles add up to be 180. Now, they did throw the numbers around the picture, which wasn't necessary, but it will be used in some of the other theorems that we have in this room.
Our group's ready to go.
Ready to go?
You have to wait your turn.
I'm gonna come back to you guys probably tomorrow. I want this group's picture for right now. I'll explain. We're gonna use yours tomorrow. All right. I want you guys to come up to the board. Hey, if you have not, this picture should be next to 6.5. Hey, what was the picture you guys chose? 15, 14.
Always.
Game's on.
I think.
All right. Okay. All right, here we go. All groups should pay attention.
Good job, Sarah.
And nobody yells at you. Everybody cheers when you.
Look at Nathan, he's doing all the
Good job, Nathan. Where's
So
that?
there,
What number is that?
Yeah.
Backwards C.
Okay. All right. This picture, as they're writing, I'd like you to put this picture next to Theorem 6.3. So open up your little tabs, put it next to 6.3, and then they can explain what they're doing here.
96, Miami LeBron.
Yeah, you want to put this next to your 6.3. All right. As you guys are writing, the group want to explain what you did?
Wrong way.
The other way.
I wrote.
Stop stirring.
15. Thanks, buddy.
Yep.
I like the
All right. Hey, guys.
Opposite sides are congruent, so we set them equal to each other.
Okay. Opposite sides are congruent. They set certain walls equal to each other, and then they're showing you the math and actually solving it. Subtracting 8 to the 14 side, dividing by 2, or dividing the other side by 3 to find y. The opposite walls are equal. That is a perfect example of 6.3. This is our last one today. I'm going to walk around. I'm going to collect my piece of paper. Hopefully you did not write on them. The visual organizer you need to keep for tomorrow. We're going to continue a couple more of these tomorrow. And then we're going to get to homework. You need some form of a textbook tomorrow.
Yay. Here, keep that.
Good job.
Like that, quit screwed out. You'll get cancer.
I've seen it.
I won't put it in.
Prove it.
Can I have a key? Give me key.
What?
Give me key.
You want cancer? Alright.
That makes 150 or something like that. And then you have to add it with the water.
Easy there. Oh, man. It's still like 36 though.
I don't think it's 36, because 36 plus 33 won't make 150. Or 180, I mean.